Zero dimension. A zero-dimensional object is just a single point. It has no length, no width, and no height. It cannot be measured in any direction, yet it still represents a precise position in space. In mathematics, it is often used to mark a location on a graph or coordinate system. Even though it has no size, it is the starting idea. One dimension. A one-dimensional object has only length. Imagine a straight line that extends in two directions but has no thickness or height. You can move forward or backward along it, but nowhere else. This idea shows up in simple paths, number lines, and even basic motion. It is limited, but it introduces the concept of direction. A two-dimensional world includes length and width, but no height. Flat surfaces like paper, screens, or drawings exist in this space. Shapes such as squares, circles, and triangles live here. Everything can be measured across and side to side, but there is no depth. This is the dimension most images and designs are based on. Three dimensions. Three dimensions add height to length and width, creating depth. This is the space we live in and experience every day. Objects have volume, and you can move up, down, forward, backward, and sideways. Everything physical, from buildings to people, exists in this dimension. It feels natural because it matches how we see and interact with the world. Four dimensions. The fourth dimension is often described as time. While the first three dimensions define space, time tracks how things change within that space. It moves in one direction, from past to future, and allows events to happen in sequence. In physics, space and time are combined into one system, showing how movement and change are connected. Five dimensions. The fifth dimension goes beyond space and time and introduces the idea of alternate possibilities. It is often imagined as a dimension where different versions of reality exist, each representing a different outcome. While it is not something we can see or measure directly, it appears in advanced theories that try to explain how multiple outcomes could exist at once. Six dimensions. The sixth dimension expands further by allowing movement across all possible timelines that could come from the same starting point. Instead of just one path through time, it includes every variation. This concept is used in theoretical physics to explore how different versions of the universe might connect or relate to each other. Seven dimensions. The seventh dimension introduces entirely different starting conditions for universes. It is not just about different outcomes from one reality, but completely different realities from the beginning. Each universe could have its own rules, constants, and structures. This idea pushes far beyond everyday experience and enters deep theoretical thinking. Eight dimensions. The eighth dimension builds on the seventh by allowing movement between all these different universes and their possible timelines. It combines variations of both starting points and outcomes. This creates an extremely complex structure where countless realities can exist and interact in ways we cannot fully visualize. Nine dimensions. The ninth dimension represents the complete set of all possible universes with all possible laws of physics. It is like a collection of every version of reality that could ever exist. In theory, nothing is left out, making it a total framework of existence at its highest level of variation. 10 dimensions. The 10th dimension is often described as the point where everything becomes unified. All possibilities, all timelines, and all universes are included in a single structure. Beyond this level, there is no further separation or variation to explore. It represents the limit of what these dimensional theories try to describe, bringing everything together into one complete system.